Lesson 2.4 is a very important section because this is where we're going to start talking about a variety of different functions. We can call this a library of functions or families of functions, but we're going to look at different functions and we're going to learn about some characteristics of functions based on the different types of equations we have. So in example 1, it says that f of x equals the square root of x. And I'm just going to draw a general shape in here, and I pre-drew my axes just to save a little bit time on video, but a square root function is going to have the general shape of this. We're starting at 0 because we know that when we're looking at square roots of numbers, we can't have negative numbers. So our x values start at 0 and it's kind of like a little swoosh to the right. Now, based on this graph, we're going to answer some questions. So the first one is our domain, and we just talked about that. We don't have any x values that are less than 0. So for our domain, our x values are all values such that x is greater than or equal to 0. All right, so this would be a good notation. We can also write this as a interval notation where we start at 0 and we include 0 and we go to infinity. And infinity never ends, so it's not a closed set, so we use a parenthesis there. Now our range, if I look at the y values, I want to know how high and low is it. It also starts at y equals 0 and goes up, and it will keep going up continuously. So we would say that the range is the y values, and y has to be greater than or equal to 0. Same thing as the domain, 0 to infinity. X-intercepts, we can see here that it crosses the x-axis at x equals 0. And this one, even, odd, or neither. Now remember, if it's an even function, we're going to reflect it over the y-axis. If it's an odd function, we're going to reflect it over the origin. So this point would go down here somewhere. And you can see that there's no reflection here, no symmetry. So this is neither, either, or even or odd. This is a function, if I start down here, it's always increasing. So we're increasing all the time, and that's from 0 to infinity. All right, we're always increasing in this section. And this does not have a maximum value because it's going to keep going up and up and up, but it does have a minimum value. And our minimum value is 0. And that happens at x equals 0. Okay, the minimum is the y value, and the y value is 0 when x is 0. All right, another example. This is the cube root of x. The graph for the cube root of x is going to look something like this. Okay, so here I've got negative numbers because we can do the cube root of a negative number, and we've got positive numbers. Notice here all of these values for x can be included in our domain, so our domain is all real numbers. And the same thing for our range. We would have to go very far left or right to get values that are up here, but it is possible if we have very large values for x that we can get large values for y. So the range is also all real numbers. The x-intercept is at x equals 0. We have an x-intercept here at the origin. Now, determining whether this is even, odd, or neither. Again, even would flip over the y-axis, so if I took this part, I would be going up over here. So it's not even, but it is odd. I can reflect points over the origin. So this one is odd. I can see that if I start all the way to the left, the graph is getting bigger the entire time across all the values of x. So this graph, the y values are always increasing. So this is an increasing graph. Nowhere in here does it go down. And it has no maximum because we can go up to infinity and down to infinity. So it has no minimum. Example 3 is an absolute value graph. And an absolute value graph is a V. So it looks kind of like this. The domain, I can put any numbers. Remember, most of the time our domain is going to be all real numbers, except for if I have those restrictions, which are in the square root, or if a denominator can equal 0. But in this case, my domain is all real numbers. And the range, if I look, I can start at 0. But when I'm doing the absolute value of a number, we know I always get a positive value. So I have no negative values for y. So my values for my range for y is that y has to be greater than or equal to 0. I have an x-intercept at the origin, so that's x equals 0. This one, looking for symmetry for even, if I flip this over the y-axis, I see some symmetry over the y-axis here, so this is an even function. Now this one, if I read this from left to right, this is going down, and then it hits the origin, and then it starts to go up. So this graph actually has some parts that are increasing and some parts that are decreasing. And we would say that it is, let's go left to right, so decreasing from infinity, or that would be negative infinity, till we get to 0. So it's decreasing from negative infinity to 0. And we don't include a vertex or a maximum or a minimum value as included in the decreasing. That's where it's changing directions. But we do know that it's going to increase from 0 to positive infinity. So this would start at 0, not including 0, and go to infinity. And we can see that this graph has a minimum value. It has a bottom of the hill, a place where it doesn't have points below it anywhere else in the graph. So it does not have a maximum because on each side here it keeps going up. But it does have a minimum, and the minimum is 0 at x equals 0. So the minimum is the y value, and the x value there is also 0. So we're not going to get as detailed on the next page, but again, I preloaded my axes here. So here's a bunch of different types of functions, and these are all the most basic form that we can see different types of equations, and we call these parent functions. Okay, that's the basic form. That means we're not adding, subtracting, multiplying, or dividing to anything inside the function. It's just basically some kind of operation on x. Now, a constant function means that the x values stay the same. I'm sorry, the y values stay the same. And here is the general formula for a constant function, and in this case, it's just a horizontal line. So in this case, if this is going through 1, y equals 1. 1 is a constant. There's no x variable. An identity function. Identity means where something equals itself. So y equals x. And this is a line. Okay, so this is a linear equation. And it is a line that is with slope 1 and going through the origin. Okay, so if I look at this point right here, this might be over 1, up 1, over 2, up 2, down 2, over to negative 2, down 2. So whatever y is, x is the same value. Okay, so this is 2, 2, 1, 1, negative 2, negative 2. X and y are the same value. A square function is also called a quadratic function. Okay, when I'm squaring the x value, this is called a quadratic function, and I'll always get a U shape. That's U. Okay, and we call that a parabola. A cubic function is where we have x to the third power, and this function looks a little bit like this, and sometimes we call this a chair function. Square root function we just did on the other side. It starts at 0 and then goes up gradually to the right. So y equals the square root of x. We also looked at the cubed root function. So y equals the cubed root of x, which we said looks a little bit like this. Oops, I forgot my x. Then we have a reciprocal function. So remember, a reciprocal function, or a reciprocal, is 1 over something. So if I have 1 over x, my graph is going to look a little bit different here because it's not going to be continuous like these other graphs are. We're actually going to have 2 parts. So we call these parts branches. And there's an imaginary line that separates those branches, and these are called asymptotes. Absolute value function, we looked at that one. That one, remember, is going to be a v. Okay, always a v. And this last one here, we don't see too often, but it's called a greatest integer function. And it might look like where the x value has to be an integer. So if I have an x value of 2, anything between 1 and 2, but not including 1, will have a y value of 2. Anything between -1 and 0 will have a y value of -2. Between 0 and 1 has a y value of 0. Okay, so here we're only looking at integers. Okay, so the integer of the closest integer for x. So if, here's an example, if I have integer of 2.3, okay, so if I go here, 2.3, my y value is going to go up to the next one, to the next integer, which is 3. Okay, that's how I would read that. All right, so these are the basic functions, and it's going to be important that we know what their graphs look like, and we'll do some practice with that. And in the next lesson, we're going to do some things to the equations where we shift them left and right and up and down, and we turn them upside down. But it's really important that we know the basic shape of the functions.